Okay, this is going to be objective 18. We are going to solve radical equations. Any questions about what we're going to be doing today? I do feel like that this lesson will be very easy for you to learn. If we're solving a radical equation, that means it involves a root. So if you have a square root, how would you get rid of a square root? Not times by 2. What's the opposite of square? Root. You would raise it. You would square it. You'd raise it to the second power. Okay? So how do you get rid of a square root? You would second power. You'd square it. Okay? How do you get rid of a third root? You would cube it. Raise it to the third power. How do you get rid of a fourth root? You would fourth it. You would raise it to the fourth power. Okay? So forth and so on. So there is a little bit of definition here. Radical equations are equations that contain radical expressions, meaning root. You might want to add that in if you tend to forget what radical means. Don't forget, as always, long gone are the days when you didn't have to worry about checking your answers, because we know that we may have extraneous solutions. Extraneous solutions occur when the resulting number does not satisfy, and notice I put something on here. It does not satisfy what? The original. Okay, remember how we talked about some people were trying to plug into like different versions of the equation? You got to go back to the original to plug in. To solve radical equations. So, based on what we already know, what do you think our very first step would be here? I don't know that you can add the 2 and 4 together. Why couldn't you add the 2 and 4 together? Because one's under the house, one's under the radical, and one's not. So what am I hearing? If we move the 4 over, what are we doing? What do I call that? We are isolating the radical, and that's what we're going to do. Okay? Very good. So we are going to move the 4 over. So, regardless of whether you have an absolute value equation, a radical equation, you're going to treat them all the same. You're going to isolate whatever you got. Get it by itself. Okay? Now my question is, how do you get rid of the radical? How do you get rid of the square root? How do I get rid of a square root? What's opposite of square root? We're going to square it. And what I do to one side, I do to the other. And then here's my jam. What happens to the square and the square root? Cancel. And then I get x plus 2 on this side. 3 squared on this side is 9. And then we just have to finish solving. What do I need to do? We need to move the 2 over, and x is equal to 7. Okay, and then we need to check it. Okay, long gone are the days where you can get by and not check. You need to check. So be very careful when you do check. Okay, if we put this in, we put in the square root of 7 plus 2. What do I have to do after the 2? Use my arrow and get out of the radical, and then hit plus 4. Okay, if I did this by hand, it would be the square root of 9 plus 4. My question is, would this be plus or minus 3? Or would this just be 3? If all I'm doing, again, if I'm doing my check step and all I'm doing is just evaluating, then the square root of 9 we're just going to say is 3. And so 7 would be equal to 7. So that does work. Okay, does everybody understand that? Okay, when am I going to make it plus or minus? When I'm solving for x. Okay, when I'm solving for x. So let's look at this one. Where did I lose you at on the other one? Did you get... Alright, so I'm going to square on this side. I'm going to square on this side. So the opposite of a square and a square root, in order to get it to go away, you got to do the opposite. Do you understand that the opposite of a square root is squaring? So this will cancel, and that leaves you simply with x plus 2. Okay? And then 3 to the, I don't know why I wrote a 3. 3 to the second power is equal to 9. And the reason why you got to do that is because if I square on one side, what you do to one side, you must do to the other. So if I square on this side, then I've got to square it on that side. And then from there, now that there's no more radical, now I can finish solving and take x equals 7. Are you okay? Let's do another one. All right, so step 1, we are going to isolate the radical. What do I need to move? The -1. So we're going to move this over and we're going to add 1. And I'm going to get the square root of y minus 2 is equal to 6. Everybody good? So how do I get rid of a square root? I need to raise it to the second power, because that's the opposite of taking a square root is squaring it, raising it to the second power. So I agree, you got to sing your song. These cancel, and you get y minus 2 equals 36. And then you move this over and add 2, so y is equal to 38. Does it check? Plug it in and check it. Make sure you use your arrow. Make sure you get it out. Does 38 work? Yes. The two sides are equal. Any questions on that? All right. What's different about this one? All right. Listen carefully, because this one gets a little more complicated, but I think you can handle it. It's got 2 radicals. My question is, can you magically get rid of both at the same time? Ta-da! No. So you must get rid of one and then to get rid of the other. So you cannot get rid of both at the same time. So this is going to become like a part 1, part 2 kind of question. You got to isolate one. Do I have one of the radicals isolated? Yes. So we can get rid of this one first. That does not mean this one's going to go away. Okay, do you understand that? So first things first is I'm going to get rid of one. Then I'm going to work to isolate the second one. Then I'm going to get rid of it. So this one, back. Let's square on both sides. What happens on this side? Cancel. And you get x minus 12. What do you think I need to do with this? It's a binomial. Can I just take the 2 to each? You got to write it twice. Remember, that little distributing the 2 to everything, that only works with monomials. If you can't remember that, always write it twice. So you have to, because it's a binomial, you've got to write this twice. And so this is good review for us. dealing with radicals, so we're going to have to FOIL this. So, x minus 12. 2 times 2. 4. 2 times negative square root of x. Now, outside, outside, inside, inside. Keep straight. Positive 2 times negative square root of x. Negative 2 times the square root of x. Everybody clear with that? Outside, outside, inside, inside. Then what's negative x? Negative square root of x times 2. Negative 2 times the square root of x. Then what's a negative times a negative? A positive. What's the square root of x times the square root of x? X. Okay? Then what we're going to do is we're going to combine like terms. So let's go ahead and combine these. X minus 12 is equal to 4 minus 4 times the square root of x plus x. Any questions on how I added those? In order to add them, they got to match radicals. You just add the outside numbers. Now, all I got to do now at this point, everybody understand? All I did so far is I got rid of the first radical and FOILed the second side. That's all I've done. To get rid of the second radical, we have to isolate him. So what should I move to the other side? Let's move the 4 over. That'll become a negative 4. Let's move the x over. That will become a negative x. So far, so good? So those cancel, and I get negative 16 is equal to what? Now, my question here is, have I isolated the radical, or do I still have a number on the outside of the radical? Yeah, I still have a number. How do I get rid of that negative 4? He's being multiplied, so I need to divide by negative 4. Okay, all I'm doing is getting the radical by itself. And a negative over negative is a positive. Now that I have isolated the second radical, now I can get rid of them. How do I get rid of a square root? I'm going to square on the other side. So this is going to be 16 is equal to x. Yes, what you do to one side, you must do to the other. Okay, in order to keep an equation balanced, you've got to do the same thing on both sides. Okay, so my question is, let's go back and check and tell me, does this work? So 16 minus 12, 16. All right, on this side, I get the square root of 4. Do I need to make that plus or minus 2, or is it just 2? Am I solving for x right now? No, I'm just working PEMDAS. So what's the square root of 4? 2. If I'm just working PEMDAS, we're just going to say 2. Okay, on this side, square root of 16 is 4. But what's 2 minus 4? Are the two sides equal? No. So what will we say about 16? Yeah, it's your word. It's extraneous. Okay, it doesn't work. It doesn't work. Any questions? So this would have no solutions. That would be the answer to the problem. No solution.
Yeah, I know, right? It's a lot of work to come up with nothing.
Yeah, I agree. I agree. All right, so how many kind of followed with me with that? Like part 1, part 2? Kind of, sort of? Did I lose anybody on that? All right, so here's my question. Can I get rid of both radicals at the same time? No. So get rid of one, isolate the other, then get rid of the second one. So do I have one that is isolated? Yes. So we can go ahead and square both sides. Okay, what happens here? Cancel, and we get x plus 15. What do I got to do with this little baby? I got to write it twice, and I'm going to have to FOIL it. And again, everybody's like, oh my gosh, but I think this is good practice for us because it's reviewing an old skill. So that's good. So this is going to be 5 times 5 is 25. What's 5 times the square root of x? 5 times square root of x. What's square root of x times 5? Same thing. What's the square root of x times square root of x? X. Very good. Okay, any questions on that? Combine your like terms. So that's going to be 10 times the square root of x. Now, what do I do right now? All I've done is gotten rid of the first radical and FOILed the second one. What I need to do is I need to isolate this guy. You isolate, once you get to here, you isolate the second one. So I'm going to let you go from here. You finish it. Okay, isolate the second radical and solve it. Yes. Okay, so does it work? Yes. Check it. Yeah, you got to put them under both. What time is it, Miss Handy? Okay. So I'm going to move this over. Those cancel, and I get negative 10 is equal to 10 times the square root of x. Then I'm going to divide both sides by 10. And I get negative 1 is equal to the square root of x. And then I'm going to square on both sides. And x is going to be equal to 1. How many got 1? Who good? When you square negative times a negative, you'll get a positive. Okay? So my question is, does 1 work? Yay or nay? Does 1 work? So if you plug in, and I like Darius asked, he said, does this mean I have to plug in 1 for both x's? Yes. Okay? Oops. Thank you. So I'm going to get the square root of 16 equals 5 plus the square root of 1. What's the square root of 16? 4. And again, we wouldn't say plus or minus 4 because I'm not solving an equation. I'm just simply working PEMDAS. Do you understand? So it's 4. Over here, the square root of 1 is 1, and 5 plus 1 is 6. Are the two sides equal? No. So there would be no solution. Okay? So is this the same thing? Not a big deal. How do you get rid of a cube root? Yeah, raise it to the third power, or cube it. Okay? Do you still have to isolate it? Yes. So what would I do? I would move the negative 4 over, and then I would divide both sides by 2, and then I would cube both sides. So try it. All right. Any questions on what I did to isolate it? So I'm going to this time raise it to the third power. So these cancel. And I get 6x minus 3 equals, what's 2 cubed? 8. So then I'm just going to move the 3 over. And 6x is equal to 11. And I'm going to divide by 6. So x is equal to 11 over 6. How many got 11 over 6? My question is, does it work when you plug it back in? Does it work? Yes, it does. Anybody need to see the check step? It does work. Okay, you always got to check to make sure. All right, let's look at this one last one and make sure we're good with that. So this goes to what we were doing earlier today, and this is why I had you do the warm-up in groups. What do we think about 3x plus 2 to the 1/3 power? That's in exponential form. I'd rather it be in radical form. Let's change it. What is it? We always divide by what? Well, that's what it's being divided by right now is 3, but what do I say 3 is? The 3 is going to be your root. You always divide by the root. So reviewing our lesson of going from exponential to radical, radical to exponential, this is the same thing as the cube root of 3x plus 2 to the what power? First power, but you don't need it. Something to the 1/3 power is the same thing as the cube root. Something to the 1/2 power is the same thing as the square root. It's what we went over there a minute ago when we did our introductory activity. Any questions on that? So try it out. Isolate it, raise it to the 3rd power on either side, and see what you get. So if I move the 1 over and subtract 1, so the cube root is equal to 3x plus 2. If I raise it to the 3rd power, so I get 3x plus 2 is equal to -1. If I subtract 2, 3x is equal to -3. And if I divide by 3, x is equal to -1. My question is, does -1 work? Yes. If you do your check step, it should work. Okay, and you can check step into this, or you can use the radical, because they're the same thing. Questions? So let's